This is another look at exercise, the exercise on matrices. This is exercise 1C, and today we're going to look at something called the determinant. The determinant is not something we've seen before, but it's relatively straightforward. I'll show you it is. Well, I say it's the determinant is relatively straightforward. It's relatively straightforward for a 2 by 2 matrix, and at this stage that's all we're looking at. But it does get more complicated when we do it for the bigger matrix, the 3 by 3 matrix. So anyway, first of all, I just want to highlight the fact, now this is one particular calculator we can use, but there's other varieties that we can use as well. And I just want to make sure that you are able to multiply these kind of matrices together and get the right answer. So for instance, this answer I think is 2002. I'll leave it to you to get the other answers because it's just a case of typing them in. But so when I times this by 4523, I think I get 2002. Will you have a go at those for me and see if you do? If you're not sure how to use a calculator, see me in class. Now, the next stage of this is that we need to be able to find the determinant of a 2 by 2 matrix. And in the last in the starter, I did show you this answer actually, the 2002 trick. Now, what I'm actually after, and this is something you're going to have to take as read as being important. If I have a matrix, doesn't matter what it is, I want to times it by another matrix. I'll call it n. M times by n. I want ideally for these things to equal 1, 0, 0, 1. You might recall that this is called the identity matrix. This is good. We like this. If we can get a matrix sums another matrix equal to the identity 1, 0, 0, 1, that is great. Now you'll notice this is actually quite close. This is the point I was going to make. This isn't the identity matrix, but it's damn close to it. You look at it and think, yeah, it's just twice as big. And for that reason, we basically say that the determinant of this matrix, and it doesn't really matter which one I choose, I think you'll find both of them are the same, but take this one here, the 4523 matrix, the determinant of this is 2. And now on the basis that the determinant of this is 2, I suppose the big question is, if I gave you a different matrix, let's say I gave you 2, 1, 8, 4. What's the determinant of this? Interestingly, the determinant of this one, determinant equals 0. That gets a special name, which I'll talk about later. This one here is 3, 2, 5, 1. What's the determinant of this? The determinant of this is actually -7. So it begs the question, how have I got these answers? It's probably worth you pausing this video for a bit and thinking to yourself, why is the determinant of 4523 equal to 2? Now it's got to be the same rule for all of these. So why is 2184 equal to 0? Why is 3251 equal to -7? And you might want to just play around with the numbers and see if you can find a rule for yourself that other people have found before you that basically will determine what the determinant of any of these matrices are. But if you don't like that kind of puzzle, you might want to just not pause the video and just see what the answer is. And this is what people have discovered, that you can find the determinant of any, notice, 2 by 2 matrix. And the 2 by 2 matrix, I'm going to call it A, B, C, D in that order. And basically you multiply AD and take away BC. AD is this diagonal, and you take away this diagonal. Everything seems to be about diagonals and matrices, you've seen that. So the determinant, now that's usually just written determinant of the matrix you're looking at. So up here, for instance, I just write determinant of matrix n. So don't know what I'm doing. Determinant n. Another way of writing it is to put the m and just put lines around it. These are the same thing. So you've got different notations for the determinant. But notice the rule. It's worth writing down. Determinant is AD minus BC. So if that's true, I'm going to bring up something now called singular matrices. The title's just gone to the top, but you get the idea. These are singular matrices, and I determine a matrix to be singular if its determinant is 0. And interesting, I think I had one just now. I just made this up at random, and it turned out to be 0. And I said at the time, bear with me, I'll tell you what that is. And this is when I tell you what it is. A singular matrix has the determinant of 0. So take this out of here. If I find the determinant of A, I do 3 times 10, which is 30, minus 6 times 5, which is 30. So obviously that is 0 when I do that sum. And therefore A is a singular matrix. Now we'll come back to that in due course. I think in the next PowerPoint we look at that and why that starts to become important. But look out for this. Singular matrix. Write down the definition. A singular matrix as a determinant of 0. And that is more or less it for this. Now, in the exercise, you'll find this is very quick. You'll get through this work, no problem at all. And we'll quickly move on to exercise 1D.